Hi Science 20 students, this is Udith again. Today we're going to talk about a few different processes called oxidation and reduction. So again, I'm going to kind of use this PowerPoint to guide us through, but we're also going to be using our periodic table. And again, I suggest that you get a piece of paper out so you can follow along with this lesson today. So the term oxidation is used to describe when an atom loses electrons. So when something loses electrons, we call that process oxidation. Now, originally the term oxidation in chemistry was used just to talk about reactions that involved oxygen, but we've actually expanded the term to include any chemical process where one substance transfers electrons to another substance. So again, oxidation has to do with loss of electrons. So we're going to look at a couple different examples here of oxidation. The first one is shown below here. So when we have a neutral atom, something like the iron atom, losing electrons, it can become a positively charged ion. And again, you can see here that it's lost 2 electrons. So again, when those electrons are on the product side of your reaction, remember that's a loss of electrons, also showing oxidation. So what is shown here down below is an example of something called a half reaction. And we're going to be using those half reactions as we go on. They also show you some half reactions in a table in your periodic table, in your data book. So this activity series, I'm just kind of keeping it at the bottom here for reference. But again, when they talk about these half reactions, we're either writing them where we have an atom becoming an ion or an ion becoming an atom. There's a couple other examples of oxidation here. So when we have a negatively charged ion, something like chlorine, for example, losing electrons and becoming a neutral atom. So here's another example. Now, this one technically is not actually wrote down here properly because if you remember, chlorine, when it's on its own, when it's as a gas, chlorine is a diatomic element, which actually means this should be Cl2, and we should actually have 2 ions being made here and 2 electrons being lost. But again, just looking at the general process, negatively charged ion loses electrons to become a neutral atom. And then the other circumstance where we can have oxidation in this half reaction form is when we have a multivalent element. So if we have something like iron, which can exist as iron 2 plus or iron 3 plus. So in this case, we have a positively charged ion. It has lost electrons and now become even more positively charged. So again, that's another example of oxidation. So again, you'll notice in all of these reactions that the electrons are on the product or the right-hand side of the reaction. So that's kind of a dead giveaway. Oh, it's oxidation because the electrons are on the right side. Now, kind of the opposite process of oxidation is called reduction. So reduction is a process when atoms gain electrons in order to become something else. So the name reduction actually comes from the metal refining industry. This is a process that they use in that industry where they take large amounts of some sort of an ore, so iron ore, for example, and they make it into smaller amounts of a pure metal, in that case, pure iron. So again, reduction can be used as a term anytime there's a gain of electrons. Excuse me. So anytime we see a gain of electrons, that process is reduction. Again, I'm going to just show you a few half reactions to give you an idea of what reduction looks like. So some examples of reduction atoms, you're going to notice that these are very similar to the last ones we saw. And look at that. They're using the chlorine example, but this time they have it written properly as Cl2. Thank goodness. So we can have neutral atoms gain electrons to become ions. In this case, the chlorine atom has gained 2 electrons in order to become 2 chlorine ions. We can have positively charged ions gain electrons to become neutral atoms. So in this case, we have our sodium ion. It gained 1 electron to become the metal atom. And the last example is similar to the last one, but kind of the opposite process. So we can have a positively charged ion gain electrons to become slightly less positively charged. And again, this one will only work for those multivalent elements. So in this case, we had our iron 3 ion gain 1 electron to become iron 2 ion. So there's a number of ways that you can use to remember oxidation and reduction. My favorite one is Leo goes grr. So what that stands for, Leo stands for lose or loss, E stands for electrons, O stands for oxidation, and then the grr is gain electrons reduction. Now, I'll tell you, on page 73 of your textbook, they give you another way to remember it, and it is the acronym oil rig. So the way to remember that, oxidation is loss, reduction is gain. And in both of those cases, again, they're talking about electrons. So the combination of these reduction and oxidations happening in one process are called redox reactions. And we're going to be looking at a few different redox reactions. So for the purposes of Science 20, these redox reactions that we're going to look at are single replacement reactions. Okay, so again, these are single replacement reactions. And these redox reactions do occur in real life. So again, I talked a little bit about the refining process earlier, where they take copper ore, iron ore, some sort of a metal ore, and they let that undergo reduction in order to become a pure metal. Now, again, if something in the reaction is gaining electrons, there has to be something present losing electrons, because where is that source of electrons coming from otherwise? So we're going to look at an example here. It says silver nitrate solution reacts with solid zinc to produce zinc nitrate solution and solid silver. So for these type of questions, they're either going to give you a balanced chemical equation, or they're going to ask you to write a balanced chemical equation. So we're going to write a balanced chemical equation to describe this reaction. Now, again, this is a skill that you should have been able to do in Science 10, so kind of a skill that's still expected of you as you move forward to Science 20. So silver nitrate solution, AgNO3, aqueous, plus solid zinc, so zinc solid, produces zinc nitrate. Now, it does say here that it is a solution, so that means it's going to be aqueous and solid silver. All right, so we've written our reaction. Now we need to balance it. So again, I'm not going to go through too much. I'll just kind of talk about what's going on in my head as I balance this reaction. So right now, silvers, they are balanced. Nitrates, they are not. Well, notice that there's 2 nitrates here, 1 nitrate here. We can balance that by putting a coefficient of 2 in front of my silver nitrate. Now my zincs are balanced, my nitrates are balanced, but my silvers are not, because I have 2 on this side and 1 on this side. So I can put the 2 there to balance it, and now we are balanced. Part B says, carefully examine each substance before and after this reaction to determine whether oxidation or reduction occurred, and we're going to use half reactions to support your answers. So this is kind of probably the first time that you're seeing these, again, writing these half reactions. You can kind of do it in whatever order, but I personally like to start with whatever was in its solid form first. So we have zinc. It's in its solid or atom form here because it's by itself. And then we'll notice here that it's going to be in its ion form because now it is in an ionic compound with another ion. So again, we have zinc on the left-hand or reactant side. And then we have zinc in its ion form on the right-hand side or the product side. So again, if you're wondering, oh, how did you know zinc was 2 plus? Just take a look at your periodic table. It tells you zinc is 2 plus right there. Now, this is where sometimes you have to think about these logically. In order for this zinc, which again is neutral over here, so you can think of it as having a charge of 0, in order for it to become the zinc ion, again, we're going to want a neutral or same charge on either side. We're going to have to add 2 electrons to the right-hand side. And now if we add positive 2 and negative 2, neutral on that side as well. So it's not always going to be neutral on both sides, but again, generally speaking, whatever this is by itself, whatever charge this has, this should have the same. Now let's take a look at the silver. On this side, it's in an ionic compound, so it's going to be in its ion form. And on the right-hand side, we see that it's in its solid form, it's by itself, so it's an atom on this side. Now, I'm going to make a note here. If there are coefficients in front, when we write our half reactions, we're not worried about these coefficients. The only time we're going to add coefficients into the half reactions is if we have one of those diatomic elements. So that example that we looked at with chlorine, where they had 2 Cl minus, that's the only time that we're going to be adding in any sort of coefficient. All right, so I'm going to leave my arrow. And then again, on this side, I have it in its atom form. Last thing I have to do is add electrons. Now, you probably already knew where the electrons went because I did kind of leave a space. But the electrons are going to go, you can either write 1E minus or just E minus. They're going to go on this side. They're going to go on the reactant side. Again, if we look at the charges now, an atom, it's neutral, it should be 0. A +1 and a -1 is also neutral, 0. So you don't actually have to write those in. That's just me showing you they're neutral. Okay, now last thing I can look at is my nitrate, the NO3. It's in an ionic compound here, so it's in ion form on this side. It's in an ionic compound here. It's in ion form as well. So actually, you'll notice that the nitrate, regardless, is in an ion form. Now, there is a special name for that we're going to look at here in a minute, but let's just finish up the rest of this question. Okay, so they did ask us to label these as oxidation or reduction. So remember, Leo goes grr. If we look at this first example, the zinc has actually lost electrons. So this is oxidation. If we look at our silver, it has picked up 1 electron. It's gained electrons. This is reduction. And lastly, the nitrate is a very special type of ion in this. It is called a spectator ion. So if you think about what the word spectator means, if you're a spectator, you're watching something, right? But you're not necessarily involved in the process. So although the nitrate is there and it is kind of involved, it's not actually changing. So it really is just a spectator. It's not really doing much other than spectating or watching the reaction. Okay. So again, this reaction shown up here where we have oxidation and reduction occurring is called a redox reaction. Now, if it wasn't already confusing, I apologize, but you guys know sometimes chemistry likes to make things a little bit more challenging, and that's okay. Now, the way I like to think about this is real estate agents. So a real estate agent, again, the word agent, they help somebody else look for their house or somebody else sell their house. Now, I know you're going to say, well, a real estate agent can sell their own house. Yes, they can. But for the purposes of remembering this, the agent is the thing that's helping something else undergo this process. So any entity that supplies, and by supplying, that means they have to lose electrons so that reduction can occur is called a reducing agent. So in this case, the zinc is the reducing agent because it lost an electron. In this case, it actually lost two, but it lost electrons so that the silver was able to gain electrons. Any entity that gains electrons, and again, by gaining electrons, it's helping something else be oxidized, is called an oxidizing agent. So again, you should know both terms, just oxidation and reduction in general, but also know what a reducing agent is versus an oxidizing agent. All right. So again, make sure you understand and know those two terms. So again, I would encourage you to do some more practice where you have to write a balanced chemical equation and then write the half reactions for what's undergoing oxidation and what's undergoing reduction. Hope you all have a wonderful day. Bye-bye.